Hello, this is Earth Science teacher Tim Martin, and in this astronomy video, I want to talk about impacts. It's an especially interesting day when bits of space or some of astronomy comes and interacts with Earth. For starters, let's make sure we understand some of the basic vocabulary. Meteoroid, meteors, and meteorites. Here we see a selection of some of the well-known asteroids. Vesta, one of the larger asteroids, is 570 kilometers across. On the other hand, Itokawa on the lower left is only 500 meters across. Truly, there's not much of a difference between an asteroid and meteoroid other than size. The smaller ones we refer to as meteoroids. A meteor, on the other hand, happens when a meteoroid is entering the Earth's atmosphere. Coming in at speeds of over 20 or 30 kilometers per second, they generate considerable friction as they go through the Earth's atmosphere, causing the outside of this rock to melt and glow. The image here shows the Chelyabinsk meteor as it exploded over northern Russia on the 15th of February 2013. Meteorites, on the other hand, are the rocks after they hit the ground. They can be divided in three categories: ones that are made out of rock, ones that are metal, and the other that are a mixture of both. Here we see a selection of three stony meteorites. The one on the left, Allen Hills 84001, is a special rock that has been studied, and it was identified that this originated from the planet Mars. Scientists were very interested in this rock because it initially appeared to have microstructures that looked similar to small fossils. The image in the center is a fragment of the Chelyabinsk meteor that fell over Russia in 2015. The metallic meteorites are often composed of the metal iron. Some have a significant amount of the metal nickel as well. Campo del Cielo is one that fell in Argentina. The other two images are from meteorites that fell in Russia and Sweden, respectively. These two have been cut, polished, and etched with acid to reveal a beautiful mineral crystal pattern inside. The third group are the stony irons. This is a slice of a meteorite that fell near Magadan, Russia. Here we can see olivine or peridot mineral crystals growing inside the metal matrix. This likely came from the core mantle transition zone in an asteroid. Many people find rocks and are curious if they have found a meteorite. Frequently, scientists refer to them as meteorongs when it turns out they're not a rock from space. A few things to check. Is your rock magnetic? Most meteorites are. Does it have a black fusion crust? As the rock burns through the Earth's atmosphere, many times it will take a darkened crust on the outside. If you have the material to cut, polish, and etch it with acid, you may be able to see the Wittgenstein pattern. This is the unique crystal structure that occurs in metallic meteorites. If it's a stony meteorite, if it's cut, polished, you may see little round spheres inside of the rock. These chondrules are leftover bits from the formation of the solar system. All of these are indicators that a rock may be a meteorite. In order to confirm whether a rock is in fact a meteorite, one must rely on doing more advanced geochemical analysis. In order to confirm a meteorite or an impact location, geochemistry is very important. It turns out that many meteorites are enriched in what we call rare earth or platinum group elements. Here, surrounded by the box, we can see elements 44, 45, and 46, and 76, 77, and 78 are relatively uncommon on planet Earth, but have a much greater frequency within meteorites. This is particularly the case for element number 77, iridium. In fact, it was a high dosage of iridium in certain geologic layers that led to the understanding that it was an asteroid impact in the northern Yucatan Peninsula area of Mexico that is responsible for the extinction of the non-avian dinosaurs 66 million years ago. These two images on the right were taken in Raton, New Mexico, and Trinidad, Colorado, where the Cretaceous-Paleogene boundary is well recorded in the geologic record. Another important feature for impact crater identification is the occurrence of impactites, specifically breccias and suavites. These are rocks that have been crushed and partially melted due to the incredible force of the asteroid impact. Here we can see several samples of impactites from the Lake Elgin crater. Another important feature for crater identification is the presence of tektites or melt glass. Melt glass are earth rocks that have been melted by the incredible heat and pressure associated with the impact. On the left, we see an image of these black stones that are very similar to obsidian. These are Philippine tektites. Libyan desert glass from the Sahara Desert has this beautiful golden color. Moldavites from the Czech Republic have this unique green color. While on expedition to Lake Elgin in northern Siberia, I was particularly excited one afternoon on a hike when we found significant quantities of Lake Elgin impact glass. You can see that the surrounding rock is mostly light brown, but the black obsidian-like impact glass was very distinctive. I was given permission by the scientific team to bring home several samples for educational and research purposes. This sample in the image below is now in the collection of the Smithsonian Institution. There are several more features that are very important for meteorite and impact crater identification. These take more technical analysis. In the rocks below the impact structure, we may find shatter cones. Due to the incredible forces during the impact, the surrounding rocks may fracture in unique ways. When a sample is examined under a microscope, sometimes mineral crystals will show small parallel lines. These planar deformation features can only form in one of two ways: as a direct result of a nuclear blast or as a result of an asteroid impact. Finally, there are certain minerals that form only under high pressures. These minerals may also be indicators that the structure was in fact an asteroid impact. Finally, crater morphology. If we're trying to identify impact craters, it's important to look at other craters, such as ones on the Moon. We can see that there are many craters that are round. Other younger craters may often show peaks or mountains in the center of the crater. Looking for characteristics of known asteroid craters, we can compare those to holes on the Earth, such as Meteor Crater, Arizona is one of the youngest and most well-preserved impact structures on planet Earth. Another more recently discovered impact structure is Upheaval Dome in Canyonlands National Park. For a long time, geologists debated on its origin. After careful mapping of the structure, including the tilted layers in the central peak and the discovery of high-pressure altered minerals, it has now been determined that Upheaval Dome is in fact an impact structure. Of course, the one that's closest to my heart is Elgin Crater, where I had the chance to participate in the International Scientific Expedition in 2009. This crater, which is 18 kilometers or 12 miles in diameter, is thought to have been formed by an asteroid nearly 1 kilometer across. Samples that I've collected confirmed through trace element geochemistry and planar deformation features that this in fact is an asteroid impact crater. By carefully studying meteorites and rocks from surrounding various areas, we now have discovered hundreds of locations all around the planet that we now know are actually asteroid impact structures. I hope you join me again for another astronomy or earth science video on the TMartScience YouTube channel. Thanks for watching.